Hello everyone, and welcome to today's presentation. I'm excited to have you here as we explore a comprehensive guide to Kotlin collections. Today, we'll cover essential topics like list, set, map, and the differences between mutable and read-only variants. We'll also dive into powerful operations such as filter, map, fold, zip, and more. Plus, I'll share some key interview questions and answers to help you strengthen your Kotlin skills. So, let's get started and discover everything you need to know about Kotlin collections. Now, let's look at the different types of collections in Kotlin. Collections come in two main variants, mutable and read-only. Mutable collections allow you to modify their contents, adding, removing, or updating elements, while read-only collections are, as the name suggests, immutable once they are created. When we talk about collections, one common type is map. Maps are collections of key-value pairs, which means each value is associated with a unique key. This makes data retrieval really efficient, especially when you need to look up values quickly based on their keys. Next, there's set. A set is an unordered collection of unique elements. You won't find duplicates in a set, which makes it perfect when you need to ensure all items are distinct without caring about their order. Then we have list. Lists are ordered collections of elements. Unlike sets, lists can contain duplicates and the order of items matters. You can access elements by their position, which makes lists very versatile. In Kotlin, collections are powerful containers that hold multiple elements, and they support various operations such as iteration, modification, and retrieval. These features are fundamental as they enable us to manage data efficiently and write cleaner, more expressive code. Now let's differentiate between list, set, and map in Kotlin, which are fundamental collection types. First, the map is a collection where each key maps to exactly one value. Think of it as a real-world dictionary, where each word key has a specific definition value. It's a collection of key-value pairs, and each key is unique within the map. Next, the set is a collection of elements that are unique, meaning no duplicates allowed. It's unordered, so the elements don't have a specific position or order, which makes it ideal when you need to ensure all items are distinct, like a collection of unique IDs. Then, the list is an ordered collection of elements where duplicates are allowed. You can think of it like a playlist, order matters, and some songs may appear multiple times. The list maintains the sequence in which you add items, making it useful when order is significant. Understanding these differences helps us choose the right collection type based on whether we need key-value pairing, uniqueness, or order. Each plays a vital role in managing data efficiently in Kotlin, aligning with our overall goal of writing clear, effective code. Let's take a closer look at this example. Val map equals map of, with A mapped to 1 and B mapped to 2. This is a collection of key-value pairs, which is a fundamental concept in Kotlin. Now, moving on to the next part, what exactly is a map in Kotlin? Think of a map as a way to store data where each item has a unique key associated with a value. It's very useful when you want to quickly look up data based on a specific identifier. When comparing lists and maps, it's important to understand their use cases. But before that, let's clarify the difference between list and mutable list. A mutable list, like mutable list of, supports adding, removing, or updating elements after its creation. So, if you need a collection that changes over time, mutable list is your go-to. On the other hand, a list created with list of is read-only. Once it's created, you can't add or remove elements. It's a fixed collection meant for situations where you need to keep data unchanged. This distinction is crucial because understanding whether you need a mutable or immutable collection helps you write safer and more predictable code, especially as your projects grow in complexity. Let's take a closer look at how we iterate over elements in Kotlin. The for-each function allows us to perform an action on each item in a collection effortlessly. Moving on, we have the map function, which transforms each element in the collection, often changing its form or value. For example, multiplying each number by 2. Then there's filter, which helps us select only the elements that meet a certain condition, like filtering out numbers greater than 5. In our example, we chain these functions together. First, we filter the list to get numbers greater than 5, then we double those numbers using map, and finally, we print each result with for each. This chaining makes our code clean and expressive. Now let's connect this to the overall theme. These functions, filter, map, and for each, are fundamental for working with collections in Kotlin. They enable us to write concise, readable code that performs complex data transformations with ease. Switching gears, let's talk about how to check if an element exists in a set. In Kotlin, this is straightforward. You can simply use the in keyword, like 3 in numbers, to verify if the number 3 is present in your set. It's a quick and intuitive way to perform membership checks, which are essential in many programming tasks. Let's talk about the difference between map and flat map and why they matter. With flat map, we're able to flatten nested lists into a single list, making it much easier to work with complex data structures. For example, if we have a list of lists, flat map combines all those inner lists into one unified list, like 1, 2, 3. On the other hand, map preserves the structure. It transforms each element but keeps the nested lists intact. So when you use map on a list of lists, you end up with a list of lists, like 1, 2, 3, which might be useful in some cases, but not when you want a flat structure. This distinction is key because it influences how we process data efficiently. Using flat map when appropriate avoids creating unnecessary nested structures, and it works hand in hand with sequences to optimize performance, especially with large datasets. So, understanding when to use map versus flat map helps us write cleaner, more efficient code, and it ties into our overall goal of optimizing data processing in Kotlin. So let's take a closer look at this example. We have a result that pairs the number 1 with A and 2 with B when we use the zip function on list of 1, 2, and list of A, B. It combines elements from both lists into pairs, creating a list of pairs like 1A, 2B. This is really useful when you want to combine two related lists into a single list of pairs, making it easier to process corresponding data together. Now moving on to the question, what is zip exactly? Well, zip takes two lists and zips them together into pairs. Think of it as pairing up items from each list based on their positions. It's quite handy in scenarios where related data is split across separate lists. Shifting gears a bit, let's talk about fold and reduce. These are both functions that help us aggregate or combine list elements into a single value. Starting with fold, it has an initial value. For example, if we have list fold 10, I plus I, it begins with 10 as the starting point, then adds each element in the list to this accumulator. This initial value is important because it sets the starting point for our calculation, giving us more control over the result. On the other hand, reduce is similar but doesn't require an initial value. When we do list reduce, I plus I, it takes the first element of the list as the starting point, then applies the operation across the rest. This makes reduce more concise, but also means we need to be sure the list isn't empty, or it'll throw an error. So, to sum it up, fold allows us to specify a starting point, making it more flexible, especially when our calculation needs an initial seed. Reduce, however, is more straightforward when the list has elements, and we want to combine them all directly. Both are powerful tools for data aggregation, and choosing between them depends on whether you need that initial value or not. Let's dive into some key points about data structures and performance. First, we have small data, which is often best represented as a list. Lists are simple, straightforward, and great for holding a collection of items. When we look at large chained operations, these are better handled with a sequence, which allows us to chain operations efficiently and lazily, improving performance when dealing with big datasets. Now to the question, which is faster, list or sequence? Well, generally, sequences can be more efficient for complex chained operations because they avoid creating intermediate collections. But for simple, direct access, lists can be just as fast or faster. Next, can a mutable list be referenced as a list? Absolutely. Since mutable list is a subtype of list, you can reference it as a list to enforce read-only semantics when needed, which helps with safer code design. Moving on to avoiding duplicates, using a set is advantageous because it inherently prevents duplicates. Plus, lookups in a set are O(1), meaning they are very fast, making sets ideal for performance-critical scenarios like managing recycler view IDs. To sum up, when choosing between these structures, consider the operation types and performance needs. Lists are great for ordered collections, sequences excel in chained, lazy operations, and sets are best when uniqueness and fast lookups matter most. These choices directly impact app performance and code safety, aligning with our overall goal of writing efficient, maintainable code. Let's talk about the purpose of the all, any, and none functions on collections in Kotlin. These functions are really useful for checking conditions across elements in a collection. The all function returns true if every element in the collection satisfies a given condition. For example, if we want to check whether all numbers are even, we can use all with a condition like it %2 = 0. Next, the any function returns true if at least one element matches the condition. So, if we want to see if there's at least one even number in our list, we use any with the same condition. And then there's none, which is true if no elements match the condition. For instance, we can check if there are no negative numbers in the list by using none with it 0. These functions help us perform quick, expressive checks on collections, making our code cleaner and more readable. They connect to the overall theme of working efficiently with collections in Kotlin, simplifying the process of testing conditions across multiple elements. So the group by function in Kotlin is really powerful. It returns a map where each key is a distinct value of the grouping criterion, and the value is a list of elements that match that key. In this example, if we use grouped by age, it would produce a map with keys like 25 and 30. For 25, the list would include Vishal and Shraddha, and for 30, it would just include Peter. This makes it easy to organize and access data based on shared attributes. It's a great tool for performing grouping operations on lists, especially when you want to categorize data efficiently. This concept ties into the overall theme of data manipulation and making your data more accessible and manageable.